G'day guys, I've got an implicit differentiation question here where it's asking us to determine the gradient of this curve at the point 5,3. So basically what I'm going to do today is I'm going to just work through this problem. I'm not going to really explain implicit differentiation per se, but I'm just making this video for those of you who want an example question of how all of the theory works in practice. So let's get straight to it. We've got this curve here which is in terms of x and y. And so what we're going to do is we're going to differentiate all of these terms with respect to x. So my first step whenever I do a question like this is it might seem tedious to you guys, but we're going to differentiate each term with respect to x. So we have d dx of 3y squared plus d dx of 4x, and that is equal to d dx of x squared plus, now this here is going to be a product rule, so we have to do the derivative of the front number times the back, so we're going to go y times d dx of 2x, so that's the derivative of the front, plus the front times the derivative of the back. So 2x times d dx of y minus d dx of 8. Now if you're in an exam, this would probably get you a mark just for doing that. You haven't actually done anything except for really writing down d dx in front of all of the terms and showing that you're going to use the product rule to differentiate this 2xy term. So what we then do is we're going to, on this first part, we're going to use the chain rule. So this one here. And what I mean by that is we're going to, in effect, we're going to take this derivative with respect to y. So we're going to have d dy of 3y squared. But we're going to then multiply that by dy dx. And the reason we do that is so these two things are equivalent, because we have d dy and dy dx. The dy's cancel and we have d dx, which is all we had at the top. But now we can actually differentiate this. So then we're going to add to that the derivative of 4x with respect to x is just 4. And that's equal to the derivative of x squared with respect to x is just 2x. The derivative of this with respect to x is just 2, and we're timesing it by y. So this is equal to 2y plus, now what have we got here? We've got 2x times dy dx. So this is going to just be dy dx times 2x. Cool. And we have dy dx of 8, which is nothing. Great. So what we're going to do is we're going to differentiate this with respect to y, and we have 6y times dy dx plus 4 is equal to, we can just write the rest of it down, 2x plus 2y plus dy dx times 2x. And now what we're going to do, a lot of people will try and solve it from here. I like to get everything on, like, have my dy dx equals something. So we'll get all of our dy dx terms on the left, and we'll move our 4 to the right. So we have 6y dy dx minus dy dx of 2x. And what we've got here on the other side is we're going to have this is equal to 2x plus 2y minus 4. We're then going to factorize this side. So we're going to have dy dx outside of 6y minus 2x is equal to 2x plus 2y minus 4. We then hopefully you guys are all following me. We then divide both sides by what's inside the bracket, so we are left with dy dx is equal to something. 2x minus, plus 2y minus 4, got ahead of myself, divided by 6y take 2x. Cool. Then what we're going to do is we're going to evaluate this derivative at 5, 3, which is equal to 2 times 5 plus 2 times 3 minus 4 divided by 6 times 3 minus 2 times 5. So 2 times 5 is 10, plus 6 is 16, take 4 is 12. And we have 18 take 10 is 8, which we can then go, well, dy dx, that's a d, evaluated at 5, 3 is equal to 3 over 2. Cool. So there you have it, guys. That is a typical exam style question for implicit differentiation. What I've done here is I've gone about this I've been quite pedantic with the way I've actually set out all of my steps. I've just done that so you guys, if you need to go back, you can follow it and just check out what the hell I was thinking. I think the two trickiest parts in this entire question are making sure that you get this bit here right. I'd say that's one of the tricky parts, and also making sure that this bit here, you use the product rule when you're differentiating it. So you have to make sure it splits like this. That's the two most, I would say, difficult parts of the question. Once you've done that and you've sort of leapfrogged over those two sort of potholes, it's basically, very elementary algebra to get to this end. So like this bit here is we're using the chain rule, and this bit here is we're using the product rule. So when you have a y function to a power, you're usually going to use the chain rule, and that should tweak you off. So that's the chain rule, and that's the product rule. And guys, you go through, you make sure that all of your components are differentiated correctly. You then get the equation dy dx in terms of both y and x on the other side, sub in your points, and how's your father, you've got to the end, all sweet. But I hope the video helped, guys. I was only just trying to get you through the question to show you how a implicit differentiation sort of theory is used in practice. If it helped, definitely give it a thumbs up. It does me a bit of does my channel a bit of good. Subscribe to my channel as well if you'd like. I put out new videos all the time on maths, physics, chemistry, anything relating to sort of getting through high school. But until next time, guys, just keep enjoying your studies.